Last lesson we learned on significant figures, standard form and prefix used in SI units. Now today we are going to learn in the oil drop experiment. Now, this is an experiment. This is an experiment that is done to determine the size, diameter, and the thickness of the oil molecule. Now, we have an experiment. How it is done. The oil patch podium powder tray. Now, in our experiment, we are going to determine the size, the thickness of this oil molecule. Now, what is the procedure? Number one is what? Answer. Number one, procedure number one.
Put water in a clean tray and sprinkle the copodium powder on the top.
Put water in a clean tray and sprinkle the copodium powder on the top. And the second procedure. Place a drop of oil on the surface of the powder water. Now the third one. Answer. The third one. The oil breaks the oil. That's not the third procedure. What is the third? The drop spread onto a thin layer, onto a thin circular film whose thickness is 1 molecule. Now the fourth one. No, raise up your hand and read. Obama, read. Now, the oil breaks the surface tension of water and hence the water towards particle spools away. Now, the fifth one, we do what? We measure
of the batch at various points and determine the average diameter.
Measure the diameter of the batch in various points, then do what? Determine the average diameter. Now we will do what? Measure our D1, D2, and D3. Then we add, and then we find the average. Now NB, the lycopodium powder is used to make the oil outline clear. Now the lycopodium powder, it will remove what? The outline of this oil patch clear, so that you can measure the diameter or the radius. Now, assumption of an oil drop. There are some assumptions we will take in this experiment of the oil drop. The first one is what? The oil drop is spherical. Now the second one. Debate.
Oil patch is circular.
The oil patch is circular. Now, that one.
The oil does not.
The oil drop does not evaporate. Now, the fifth one.
The oil patch is monolayer.
The oil patch is monolayer. Now, the other one. Evans.
The molecules are like small,
The molecules are
like small.
small cube with no space between them. And then the last one, the size of one molecule is equal to thickness of an oil patch. Now, our next step is what? Doing calculation of the oil drop. Now, here calculations. The volume of the spherical drop is like finding the volume of a sphere. What is the volume of a sphere? 4/3 pi r cube. 4/3 pi r cube. Now, what about the volume? The volume of the circular patch. What about that one? Volume is equals to base area times what? Times thickness. Here is a V is equals to base area times T. Now it is equals to pi r square T. Now the volume of a spherical drop is equal to the volume of the circular film. What is meant by that statement is that when we say find the volume of an oil drop, of a spherical drop, it's like saying we find a volume of a circular film, because we can find the radius of the circular film. Senor? Yes. Now, examples. Our first example. In an experiment, we estimate the size of an oil molecule. Oil drop of an oil molecule of volume. Volume what? Volume, we have our volume as what? 5.0 times 10 raised to -3 millimeter cube. Was placed on a water surface. The oil spread onto the patch of area 2.0 times 10 raised to 4 millimeter square. Estimate the size of an oil molecule. Estimate the size. Now, when we say estimate the size of an oil molecule, and we say estimate the thickness of the oil molecule, what does we mean when we say that? We are looking for what? We are looking for thickness. Even here, when we say the size, estimate the size of the oil molecule, we are looking for the thickness. Okay? Now, here, our formula will be H is equals to volume all over area. Now we have now our volume and we have our area. Now our volume is 5.0 times 10 raised to negative 3 millimeter cube. All over area, which is 2.0, 2.0 times 10 raised to 4 millimeter square. Now, key in our calculator. What do we get? What do we get? Uh-huh.
2.5 times 10 raised to negative 7.
2.5 times 10 raised to negative 7 millimeter square. Now, let's convert it into meters. When you convert it into meters, because in physics we don't leave our answer when its SI unit is not in either meters or in measurements. It is always in meters, and when it is in kilograms, you must. When it is in grams, you must put it in kilograms or newtons. Okay. Now let's put here in meters square. Now it will be 2.5 times 10 negative 7. Now into centimeters. When we put 10, it will be millimeters to centimeters. Then we add 2 zeros. Will be from centimeters to meters. Now here, because we have here in raised to negative 7, what will be our answer? 2.5 times 10 raised to negative 10 meter square. Now, are we understood? You have seen clearly that when we divide here, divide by 1,000, the negative here will add to 3. With this, times 10 raised to negative 10 from negative 7. Now, our second example. Now, someone to read for us. Our second example. Now, Evans, read for us. Yes.
A drop of oil volume 6 times 10 raised to negative 4.
Volume
6
0 times 10
raised to
negative 4
centimeter cube.
centimeter cube. Spread to form an area of 3.0 times 10 raised to 5 centimeter square. Now, what are we doing? What is the question? Calculate the thickness. Now, the thickness will be the height. Secure? Yeah. Height h is equals to volume all over area. Now we have our volume as 6.0 times 10 raised to negative 4 divided by 3.0 times 10 raised to 5. Now key in our calculator, in your calculator, and see what do you get. What do you get? 2.0 times 10 raised to negative 9 centimeter square. Now we have it in centimeter square. What do we do here? 2.0 times 10 raised to negative 9 all over 100 into meters. Now it will be 2.0 times 10 raised to negative 11 meter. Now someone to come and try this example. Now Elvis, come and try it. An oil drop forms. An oil drop forms. An oil drop forms a circular patch of area 5.0 times 10 raised to -3 meters square. If the oil drop has a volume of 9.0 times 10 raised to -12 meter cube, estimate the diameter of the oil molecule. Estimate the diameter of the oil molecule. Now here, let me give you a hint. Here we have our area and we have our volume. Now, what do we look here? Let's look first for the radius. Our radius. How do we find our radius? If it is 4/3 pi r cube, we find what? A volume. Then equate that equation. And that's the correct way. Now give him the calculator. Even you try to make some calculations. Don't just look. Make some trials. Let me see. We are doing. Do it here. Let me see. Do it 4/3 pi r cube is equals to. Now we have the pi as 22/7. Our pi is 22/7 or 3.142. So I think there, what do we do? We find the cube root of 9.0 times 10 raised to -12 times 21/88. Let's put in the answer. What is the answer? 1 point what? And what is your answer? 1.29 times 10 raised to 10 raised to negative 4, and yours? 1.29 times 10 raised to negative 4, yours? Now, our answer will be what? What is our unit? Don't leave your answer without any unit. You don't know if it is kilograms, if it is meters, centimeters, millimeters, or what? Meters. Now, that's the correct. Wait. Now, let's appreciate him. Only one clap. Yes. Now, let's do another example for you to understand better. Now, come and do this. In an experiment to estimate the thickness of an oil molecule, an oil drop of radius, right up there, radius 3 millimeters, spread over a circular part of radius, and a circular part 100 millimeters. Determine the volume of an oil drop. Now, here we have in an experiment to estimate a thickness of oil molecule. Now, Roman 1, it says what? The volume of the oil drop. Now, what is the volume? What is the formula for finding the volume of an oil drop? Over 3 pi r, and we have the oil drop of radius 3 millimeters. Now we use our 3 millimeters to find the radius of the oil drop. To find the volume of the oil drop. Now let's do together. We have a radius of 3 millimeters, and our formula is 4 over 3 pi r cube. Let's give him the calculator. What's your answer? Let me see your answer. Yes, be seated and do some calculation. Don't just sit down and watch us. Do some calculations. What's your answer? Volume is equal to what? 100 and is that the correct answer? Let's confirm together. Our volume is 4 over 3. Thank you. 4 over 3 times 5 times also will be 113.14 millimeter cube. Now, our next question is the area of the patch covered by the oil. Now, Kevin, go and do that one. Our area, the formula is pi r square, and we have our radius as what? 100 millimeters. Even you do some calculations. Pi r square, and we have our radius as 100 millimeters. What do you get? No, our formula is what? Pi r squared, my friend. This operation very fast. Our formula is pi r squared. We're heading towards the wrong direction, my friend. Go and sit down. And watch us doing. Stop. Sitting behind there and just sleeping. Okay? Now, our area is equal to what? Pi r squared. Now, our area is equal to pi, which is 22/7 times r squared, which is 100 squared. What is the answer? Our answer, area will be what? That one, 428.5 millimeter square. Now, our next question will be what? Our next question will be the thickness of an oil molecule. The thickness of an oil molecule. Now, who will come and do that? Raise your hand. The thickness with this volume all over area. We have volume and we have our area. Who will come and do that? Now, Kevin, come and do it. Do it. Don't just sit down. Make some calculations. Okay, the moment. Is this millimeters or meters? Is it millimeter square? Now we have 3.5 times 10 raised to negative 3 millimeter square. Now we have to convert into meters. Now we put 10 and then 0, 0. Now, our answer will be what? 3.5 times 10 raised to negative 6. Now, we still have some more examples. Who has not understand what we are doing here? Who has not understand? Who has not understand? I can see everybody is okay. Now, let's go back and summarize our topic, since we have come to an end of the topic. measurement 2. Now, we started by what? We started by Ofania caliper. We say you must read and do some calculations. What is the use of a Ofania caliper? Used to measure what? Either length or a diameter of something. Now we go to our zero errors and positive and negative zero errors of the vernier caliper. Our next, we went to micrometer, screw gauge. We say how to read the thimble scale and the slip scale. Now we look at again the positive errors and the negative errors. Then we come to significant figures and what? And standard forms. After standard forms, we go to prefix and now today we look at the oil drop experiment. We have now able to estimate the thickness and the size of an oil molecule. The thickness of the oil molecule is found by doing the volume all over area. And the volume, what is the formula of finding the volume? 4/3 pi r square. What about area? Raise your hand. Area. Just Kevin. Pi r square. Now, do more examples because I can't see any hard question here. Meet next lesson when we are going to start our new topic in turning effect over force.